Hello everyone, myself Om Anand Jha. I'm here with my teammates Om Trivedi and Om Lanke, and together we will presenting the 01 knapsack problem using dynamic programming. The 01 knapsack is a classical problem. You are given a set of items, each with a weight and a value, and a knapsack with a maximum weight capacity. The goal is to choose a subset of these items to maximize the total value without exceeding the knapsack capacity. The 01 part means we either take the entire item or leave it. We can't take fractions. To solve this efficiently, we use dynamic programming. Instead of trying every possible combination, which will take exponential time, we build a table where each entry represents the maximum value achievable with a certain number of items and a certain weight capacity. This bottom-up approach allows us to reuse previous result and drastically reduce time complexity to order of n into w, where n is the number of items and w is the knapsack capacity. In our demonstration, we'll walk you through how the table is built and how the optimal solution is retrieved.
Hi, I'm Om Lanke, and I'm here to demonstrate the knapsack simulator. So let's start from the top. At the top here, we have the basic controls of the simulator. These include the play button, the step forward reset. We can adjust the speed, and we can also control which mode the simulator should work in. At the left, we can input parameters. We can input the capacity, the items, and so on. In the middle here is where we will see all the actual algorithm being run, each step, and the chart, that table, we'll see that here. And at the right, we can see a visualization of the knapsack along with the total value and total weight. So let's start with an example. Here, we can input a capacity and the items, but I'll just select a sample problem. Let's see this one. So as we can see, these are the items which have been added. 5 items have been added, as we can see here and here as well. The capacity of the knapsack is 15, which is reflected here as well as here. And this is the initial value of the table. We'll select the 01 knapsack, load the problem. Okay. And now we can start the visualization. So it will go over each element just like we do in the algorithm, and it will uh, run the algorithm on it. We can adjust the speed. So now we can see that because this is quite slow, we'll go to 4 times the speed, and we can see the values being updated. Let's just wait for this to finish. And there we have it. The total, the maximum value we can get in this knapsack is 21, which is by selecting these 2 items, 2 out of 5. We'll also get a summary of this, which is another representation, and this is the algorithm explanation. We can also try out the fractional knapsack in the same problem, and this uses the greedy algorithm as mentioned. So using the greedy algorithm, we calculate the ratios, and it will select it accordingly in the fractional values as well. And this is the answer for the fractional knapsack. We have also implemented a help menu, which is which describes what the algorithm is and how you can use the simulator.
Hello, I'm Om Trivedi and I'll tell you about the implementation. So this is our website, Knapsack Limiter. At a first glance, you can tell there are a lot of containers right here. One is this header container which contains the controls as well as this info modal. And here is the input container and then the knapsack container where you can visualize the sack, as well as this container which contains the table for the O1 knapsack dynamic programming table and the fractional knapsack greedy table. So let us go right into the code. So we have used React for building the front end, and Vite as the development server, and we have used Tailwind for CSS framework, and also we have used Anime.js and Framer Motion for certain animations within the site. so that it looks a lot more beautiful, interactive, and intuitive. And going further with the code, as you can see, this is the app.jx, which is the main, you could say, file, all the important aspects of the website. And here you can see there are header ports. So header folder, so basically this import, this component import is this, and there are two table imports. One is dp table, one is greedy table. So dp table is the knapsack, and fractional table is greedy table. So basically we are doing conditional rendering on the mode. So if it is 0 1 knapsack, then the dp table is rendered. So I'll just show a problem. So this is the dp table, and when I change the mode, then the conditional rendering occurs, and as you can see, now this is the greedy table. So yeah, so this was about the table. Then there is summary. So when the code has run, so here at the bottom there is a summary container which basically gives you a summary of what the algorithm had done. So this was the basic. I mean, you could look at the code. This is the table. We have used anime.js for the cell changing animations for this knapsack problem, and for this fractional problem, this coloring and how everything is done, that is done through anime.js.